Breaker tripping is a common electrical problem that signals an overcurrent or ground fault condition within a circuit. Understanding the reasons behind breaker trips and adopting a systematic troubleshooting approach is crucial for ensuring electrical safety and preventing damage to equipment and wiring. A circuit breaker is a safety device designed to protect an electrical circuit from damage caused by excess current from an overload or short circuit. Its basic function is to interrupt current flow after a fault is detected. Unlike a fuse, which operates once and then has to be replaced, a circuit breaker can be reset either manually or automatically to resume normal operation. Circuit breakers are made in varying sizes, from small devices that protect individual household appliances up to large switchgear designed to protect high-voltage circuits feeding an entire city. There are several types of circuit breakers categorized by their operating mechanisms, trip characteristics, and applications. Firstly, thermal circuit breakers operate on the principle of thermal expansion. They contain a bimetallic strip that heats up and bends when the current exceeds the rated value. This bending action trips the breaker. Secondly, magnetic circuit breakers use an electromagnet to trip the breaker. When the current exceeds the rated value, the magnetic field becomes strong enough to attract a lever, which trips the breaker. Thirdly, solid-state circuit breakers use electronic components to sense the current and trip the breaker. These are often used in more sophisticated applications where precise control and faster response times are required. Arc fault circuit interrupters, or RSIs, are designed to protect against electrical fires caused by arcing faults. These breakers can detect the unique signatures of arcing faults and trip the circuit, even if the current is below the level that would trip a standard breaker. Ground fault circuit interrupters, or GFCIs, are designed to protect against electrical shock. They monitor the current balance between the hot and neutral conductors and trip the circuit if there is an imbalance, which indicates that current is flowing through an unintended path, such as a person. Breakers are rated by their amperage, which is the maximum current they can carry without tripping, and their voltage, which is the maximum voltage they can safely interrupt. Choosing the correct breaker for an application is essential for safety and performance. An undersized breaker will trip frequently, while an oversized breaker may not protect the circuit adequately. When a breaker trips, it is crucial to identify and resolve the underlying cause before resetting it. Repeatedly resetting a breaker without addressing the problem can lead to overheating, damage to wiring, and potentially electrical fires. To troubleshoot a breaker trip, firstly, identify the circuit that is tripping. The electrical panel will have labels indicating which breaker controls which circuit. If the labels are unclear, systematically turn off breakers one by one until the affected circuit is identified. Secondly, inspect the appliances and devices on the circuit. Look for any signs of damage, such as frayed cords, loose connections, or overheating. Disconnect any appliances that appear to be faulty. Thirdly, check for overloaded circuits. An overloaded circuit occurs when too many devices are drawing power from the same circuit. This can be resolved by moving some of the devices to a different circuit or by using a higher amperage breaker if the wiring is rated for it. Consult with a qualified electrician before increasing the breaker size. Fourthly, examine the wiring for short circuits. A short circuit occurs when a hot wire comes into contact with a neutral wire or a ground wire. This can be caused by damaged insulation, loose connections, or faulty wiring. Short circuits typically result in immediate breaker trips. Fifthly, test for ground faults. A ground fault occurs when current flows through an unintended path to ground. This can be caused by damaged insulation, moisture, or faulty equipment. GFCIs are designed to detect ground faults and trip the circuit. Sixthly, use a multimeter to test the continuity of the circuit. Disconnect the power and use a multimeter to check for continuity between the hot, neutral, and ground wires. Continuity between the hot and neutral or ground wires indicates a short circuit. Seventhly, check the breaker itself. Circuit breakers can fail over time. If the breaker trips repeatedly even when there is no apparent overload or fault, it may need to be replaced. Eighthly, consult with a qualified electrician. If troubleshooting the breaker trip proves difficult or if there are any doubts about electrical safety, it is best to seek the assistance of a qualified electrician. Electricians have the expertise and equipment to diagnose and repair electrical problems safely and effectively. Preventing breaker trips involves implementing several measures to ensure the electrical system is operating within its design limits. Firstly, avoid overloading circuits. Distribute the electrical load evenly across multiple circuits to prevent any one circuit from being overloaded. Secondly, use energy-efficient appliances. Energy-efficient appliances draw less power, reducing the load on the electrical system. Thirdly, inspect and maintain electrical wiring regularly. Check for signs of damage such as frayed cords, loose connections, or overheating. Repair or replace any faulty wiring promptly. Fourthly, install surge protectors. Surge protectors protect electronic devices from voltage spikes, which can damage equipment and cause breakers to trip. Fifthly, use appropriate sized breakers. Ensure that the breakers are properly sized for the circuits they protect. An undersized breaker will trip frequently, while an oversized breaker may not provide adequate protection. Sixthly, consider whole house surge protection. A whole house surge protector protects the entire electrical system from voltage spikes caused by lightning or other power surges. This can help to prevent damage to appliances and equipment and reduce the risk of breaker trips. Seventhly, ensure proper grounding. Proper grounding is essential for electrical safety. It provides a path for fault current to flow back to the source, allowing the breaker to trip and to energize the circuit. Eighthly, upgrade aging electrical systems. If the electrical system is old or outdated, consider upgrading it to meet current safety standards and accommodate modern electrical loads. This may involve replacing wiring, adding circuits, and installing new breakers. The National Electrical Code, or NEC, provides comprehensive guidelines for electrical installations and safety. Following the NEC requirements is essential for ensuring electrical safety and preventing breaker trips. Some key NEC requirements related to breaker tripping include: firstly, circuit breaker sizing. The NEC specifies the maximum breaker size for different types of circuits based on the wire size and the load served. Secondly, overcurrent protection. The NEC requires overcurrent protection for all electrical circuits to protect against overloads and short circuits. Thirdly, ground fault protection. The NEC requires ground fault protection for certain circuits, such as those serving bathrooms, kitchens, and outdoor areas. Fourthly, arc fault protection. The NEC requires arc fault protection for bedroom circuits to protect against electrical fires. Fifthly, wiring methods. The NEC specifies the acceptable wiring methods for different types of installations. These methods are designed to minimize the risk of electrical faults and ensure safe operation. Sixthly, grounding and bonding. The NEC requires proper grounding and bonding to provide a path for fault current to flow back to the source and to minimize the risk of electrical shock. Breaker tripping can also be caused by external factors such as power outages, lightning strikes, and voltage fluctuations. Power outages can cause breakers to trip when the power is restored, especially if there are many devices drawing power simultaneously. Lightning strikes can cause voltage surges that can damage equipment and trip breakers. Voltage fluctuations can also cause breakers to trip, especially if the voltage drops too low. To mitigate the risk of breaker trips caused by external factors, firstly, install surge protection devices. Surge protectors can protect electronic devices from voltage spikes caused by lightning or power surges. Secondly, use uninterruptible power supplies or UPSs for critical equipment. UPS provide backup power during power outages, preventing equipment from shutting down abruptly and potentially tripping breakers. Thirdly, monitor voltage levels. If voltage fluctuations are a frequent problem, consider installing a voltage monitor to track voltage levels and identify potential problems. Fourthly, consult with the utility company. If power outages or voltage fluctuations are frequent, contact the utility company to report the problem and request assistance. By understanding the reasons behind breaker trips and implementing a systematic troubleshooting approach, electrical safety can be ensured, prevent damage to equipment and wiring, and maintain a reliable electrical system. Remember, if you are not comfortable working with electricity or if you are unsure about any aspect of electrical safety, it is always best to consult with a qualified electrician.